All right, so we're going to go through the Algebra 1 practice test. This is without a calculator, so here we go. All right, the first one is choose the function shown here. Right, and it gives you this hint that it's 3 to the x. And since this, these are different functions. So here's a function, and if you look here, this is a 1 with an input to the 1. Your x equals 1, and your y equals 1. So that's a 1-to-1 ratio. And then you look at your x equals 1, your y, x equals 2. X equals 2, your y is like way up here. It's like, you could look like it would almost meet like 8. Like it was 8, right? So that's like 2 cubed. So it looks like this is a cubic function, right? And also, you have values for a -1. X is -1, your y equals a negative something 8. Right, so that only happens if in a cubic function can you get a return for negative. All right, so this is probably a cubic function, and it looks like it would intercept at -8. All right, so here you have y equals 3 to the something x, right? Your variable is the exponent, making this an exponential function. Okay, so here we go, moving on to this one here. Find the value of f sub x. Remember, your input is your -2, your x value, and then your output is your y value, or your input is your horizontal axis, also known as your domain, and your output is your range. Right, so an f of -2, would give you a y value of 3. So at this point here is -2, 3. This is your input, this is your output, okay, of the function. Right, f sub 1, so f sub 1 is your input is 1, your output would be 1. So f sub 1 equals 1. Okay, so then we have your output here. Your output is 0. So when your output is 0, well, so is your input in this circumstance. Your input is also 0 because your x value is 0 in that situation. Okay, so moving on to the table form of this. Okay, we have m sub 8, right? So this is my input, this is my output, my domain, my range, my input, my output. Okay, so my input is 8, giving me an output of 2. My input is -24, giving me an output of -13. Okay, my output is 0, giving me an input of 3. Okay, so that's how that whole thing works. All right, so here is m sub. So here's a function. This function models the number of miles in millions that passengers traveled on a train from 1970 to 2000, where x is the number of years since 1970. So this is your time initial in 1970. So find m sub 5. Right. So all we got to do here is I have another color. I have an orange. Right. So I have m. So maybe I can brighten this. How do I brighten this? Brighten. Yeah, there we go. I can brighten this a little bit. So I'm gonna take x4 times, leave my x's blank, minus 200, leave my x's blank, plus 4179. Important that you copy down everything right so you don't have any transcription errors. Then I'm going to take 5, my input to the function, and put it down in here and write down all my 5s in there, and then I'm going to do the math. So 5 squared is 25, so 25, and that's still times 4 minus 5 times 200, So 5 times 100 is 500. 5 times 200 is 1,000. Okay, and then plus 5179. Okay, so from here we are going to just combine everything. All right, so 4 times 25 is 100 minus 1,000. That equals negative 900. That's negative 900 plus 5179. So now we're going to do 5179 minus 900, because that is the equivalency. I'm adding these two terms together. Negative 900, I'm combining these two terms. Negative 900 and 5179. So that's 0, that's 0, and then 51 minus 9 is 40. No, that's not 0. That's 9 and 7. What am I thinking? That was almost an error. 79, and then 51 minus 9 is going to be 48. So the answer is going to be 48. That's a 7. 4879 million miles. So 4879 million miles. So from now we're going to say interpret this m sub 5 for the given context. So what does it mean? Oh, wait a minute, hold on. no, not 4879, 4279, what am I thinking? 4279, 4279, that would have been an error, 4279, because 51 minus 9 is 42. Okay. So give m sub 5 for the given context. So this means that from the initial point, from 1970 all the way up to 1975, 279 million miles were traveled by passengers. And that's what all that means. Okay. Next one. Now we have this represents the cost of buying a certain number of concert tickets, and then this is a coupon. Okay, T is the number of tickets. Okay, find C sub 4. Right, so we bought 4 tickets, right, at that much each, and then we got a $16.75 coupon. Okay, so C sub 4. Well, that should be a different color. C sub 4 equals, it's going to be 2550 times our T value, which is 4, minus our coupon of $16.75. Right, so 25 times 4 is 100, and then we have the 50 times 4 is $2. So this is going to be $102 minus $16.75. So $102 minus $16.75. Let's see, is it going to be, $2 minus 75, that's going to be $1.25. Maybe line these up better so it's easier to. $16.75. Okay, so I got $102 minus $16.75. All right, so I'm going to borrow a 10 from there, which I kind of don't need to, but all right, so let's see. I'm going to have let's see if this was let's see, $2. We could take it down to, let's be $14.75 off of that. to make it down to 100. So 100 minus 1475. Okay, I'm gonna add a quarter, make it, I don't need to add a quarter. Okay, so make it 15 bucks. So that's gonna be 85 bucks minus a quarter. That's gonna be 84.75, 84.25. So there we go, 84.25. Oh, sorry, let me do that again. So I'm going to take off 10 first. So I'll make it 92 bucks. So that's going to be 675 remaining. And then let's do minus 6 bucks. So that's going to give me 86, 86 bucks, then minus another 75. That's going to be 85.25. So that's a good, easy way to do it. That's the way I kind of do it in my head with money. All right, so that's going to be 85.25. Sorry about that. 85.25 right there. All right. So moving on to the next one. All right, so here we go. We have to evaluate these and make them simplified and solve for x here. Okay, so these all have the same base. So since these all have the same base, you can kind of like dismiss them and say x equals, and then what do you do when you have the same bases? What do you do with the fractions? Well, if they have the same bases and the fractions are being, and these are being multiplied together, you have to add the exponents. So you'd be adding 23.6 plus 7.6, right? So because this would be, remember, this would be 4 to the 23rd 6 plus 7.6 equals 4x. And then you could just get rid of the 4's here and just have x equal this. Okay? So then here you can just have that equals 30 over 6, and 30 over 6 equals 5. So x equals 5. Okay, moving on to this one here. All right, here we have y, or 5 to the 32nd equals 5y to the 8th. So this is going to be 5 to the 32nd equals 5 times 8y. The 5's are the same base, so you can get rid of the 5's. 32 equals 8y. Divide both sides by 8y. 8y, so the 8's cancel out, and 32 divided by 2 is 4. So 4 equals y, or y equals 4. Same thing. Okay, here's a 45 to the 1/4. Okay, and then a 45 to the k root. All right, so this is the easiest way to do this, is to say, hey, I'm going to rewrite this as a radical. Okay, so the denominator becomes the index. All right, so this is the cube root of 40, or the 4th root of 45, and all this goes to the first power, so it's just to the first, no big deal, equals 45k. Right, the 45s are the same root, so you can just say 4 equals k equals 4. K equals 4. So that's pretty cool. Okay, so the next one here is we have these bases, the same base equals these bases raised to the fractions. Right, so if you have one fraction, or one base with a fraction, or with an exponent divided by that same base raised to an exponent, it is the same thing as that base and then the numerator minus the denominator exponent. Okay, and since these have the same base, you can roll out the bases and say n equals 6 divided by 6 sevenths minus 13 sevenths equals, let's see, 6 minus 13 is going to be negative 7 sevenths equals negative 1. So n equals negative 1. So there's that one. Okay, that's number 7. Number 7 here. All right, so way to save time here is to say, okay, which ones are equivalent, is figure out one that is equivalent to the rest of them. So I have no reason not to start with A here, okay, or B here, okay. I like to start with A. So this is easy because it's just one exponent raised to another exponent, and this is 3. And remember, these are here. You just multiply the inner exponent times the outer exponent to make this 4 to the 3 halves. Sorry, so it's just going to be, this is going to be A. A is 4 to the 3 halves. Now, there's another one, 4 to the 3 halves. No, it's got equivalent to 8. Right? So which one is equivalent to 8? Well, here, this one is the easiest one to try to figure out what is equivalent to 8. So C, the square root of 4, the square root of 4 to the thirds, well, we have square root of 4 is 2 to the thirds. 2 times 2 is 4, times 2 is 8. So C is 8. So C is definitely what we're trying to look for. So we're going to try to find stuff that is equivalent to C, right? So is A equivalent to C? Well, how do you write this in radical form? Well, the 4 is the base. The denominator is that 2's are invisible and 3's are there. So yep, A is also that. Okay, you can write the 3 inside or outside. 2's are invisible, so B is the same. Okay, D, okay, 4 to the 3 halves, right, is the same as that's what we already identified it as. So C, or D is correct. Okay, 4 to the 2/3 is not the same as 4 to the 3 halves, right? So this is not correct. How about 4/3 or 4 1/3 to the 2? Well, this is the same as this, right? So this is not correct. So not correct, not correct, 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 correct. Okay, same thing here. What is the equivalent of the cube or the square root of 500? Well, what's the square root of 500 equal? Let's break this down. Square root of 500, let's do 50 and 10. 50 times 10. Well, let's break that down even further. Let's do, you know what, let's do not 50 and 10, let's do 5. 5 times 100, because there's a nice square right there. Pull that out as a 10. So we have 10 and the square root of 5. All right. So 10 to the square root of 5. Well, there's the first one. That's 5 square root of 10. That's not correct. 10 square root of 5. There's one. Well, if I put 5 back in, it turns into 25. 25 times 10 is square root of 250. That's not correct. Nope. Okay, let's do that one later. If I put 5 back in, it turns into 25. Then, so this is F. F is square root of 525 times 20. So 25 times 2 is 50. Add a 0. That is 500. So F is true. Okay. So F is true. Square root of 500. Okay, and then we have these other ones to figure out. Okay, let's look at this one. Let's do C here. C is 4 squared to the third times square root of 5. All right, so the square root of 5 is the square root of 5. So that's 4. What's 4 squared to the third? Well, 4 squared is 2. To the third is 8. Put 8 into the square root of 5. It becomes 5 times 64. Right, so 5 times, that's no way that, so 5 times, that's 20, that's not 500. It's not 500, because that's not going to be, so not C. Okay, I'm not going to waste my time doing the math. It's not 500. Okay, then we have 10 to the square root cubed. All right, so 10 to the square root. We're going to do 10 to the square root cubed. Square root of 10 is something inconvenient. So we're going to do 10 cubed squared. Oh boy. All right, so 10 times 10 is 100 times 10 is 1,000, and the square root of 1,000, I believe, is 31. Is like a messy number, and the square root of, okay, so this is going to be, how about if we break this down into, nope, can't do that. I don't see this working out anyway, so I don't think it's D. I don't see that working out as anything. All right, now the next one is going to be 5. Well, look at this. This is 100 to the first, right? Because that's 100 to the 1 over 1, right? Because you have to multiply 1/2 times 2, which is just 1. So 5 times 100 is 500, right? But that's not the square root of 500. That's 5 times 100. So that is not correct, right? So E is not it either. So we only have 2 answers to those 2. Okay, so I hope that one is clear. All right, and now we have the last page, I believe. Yep, last page is number 9. Number 9, we have 49 to the 1/2, which can be rewritten as the square root of 49. And we have 2/3, or 2 to the 3, which can be written as 2 times 2 is 4, times 2 is 8. All right, so the square root of 49 is 7, so 7 times 8 is 56. All right, so 56. Next one. All right, 6 to the 1, rewritten as 6 over 1, and then 4 to the 4/2 is 4 squared, the square root of 4 over 4. Okay, so 6 to the 1/2 can be written as, this is going to be square root of 4. We're going to send this to the bottom. We're going to send this to the bottom of this fraction. Okay, this whole thing is going to be one fraction. Okay, so we're going to have this whole thing as one fraction over 1. Okay, and that equals, so this is remember, square root of 4 over square root of 4. This is equal to 4 to the 4th. That's what that equals. Okay, so our next line is going to be square root of 4 is 2, and it's going to be the 4th over 6. Okay, so 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th is 16. 16 over 6. Let's see, divide by 2 gives us 8 over 3. So that's 8/3. All right, so next one. Here we have square root of 50 plus square root of 18 plus square root of 32. Remember, two things must be met in order to add or subtract radicals, or like to combine radicals together with addition or subtraction. Combine like terms. One, the base must be the same, and the index must be the same. Okay, so let's break these down into common things. All right, so 50 can break down into, hey, I like 5 and 2, or no, sorry, 5 and 10. Or I like 25 and 2, actually. I like 25 and 2. I like 25 and 2. 25 and 2, why 25? Because 25 is a perfect square, so 5 can come out, leaving just the 2 in there, so this is 5 square root of 2. So I'm probably going to be bringing out 2's, right? And so if I bring out a 2 of this one, it's going to be plus, probably going to be a 9 and a 2, so the 3 is going to come out of there. So this is going to be 3 square root of 2 minus, and I do a 2 here, 2 and 16, meaning the 4 is going to come out. So it's going to be 4 square root of 16. So now I can add, oops, that's wrong. 4 square root of 2. 4 square root of 2. Okay, so now I can combine like terms. 5 plus 3 is 8 square root of 2 minus 4 square root of 2 equals 4 square root of 2, which is my final answer. Okay, finally, two things under a radical multiplied together equals that, those two things squared under the radical equals that, because the square and the radical, the squared radical clear each other. Or you can say 14 times 14, let's see, 14 times 14 is 196, okay, if you wanted to do that math. And the square root of 196 is 14. It's 14. All right, just know if you multiply to the same thing inside the radicals together, it equals that same thing. Okay, so here we go. We have these two things added together, which means we probably need to get the same base because these have the same index, so we can add them together. All right, so we're going to pull down 3, put the radical up, add it, the 7, put the radical up. I'm going to start with this 12 and dissect this 12 first, because it's going to give me a good indicator of what I need to leave in here, what I need to dissect that 108 by. So 12 is going to be, maybe it's a 3 and a 4, so I can pull a 4 out of there and a 3, so that square root of 2, that 4 is the square root of 4 is 2, so I can bring that 2 out, leaving me with 17 times 2 is 14 square root of 3. So the 4 get pulled out as a 2, multiplied by the 7, leaves me 14 with the square root of 3 all left by itself. So I'm probably going to have to do 108. 108 divided by, it's 8, divided by 3. So 108 divided by 3, not to be confused with a square root of 3 times 108, but I'm dividing 108 divided by 3 now to see what my factors can be. All right, so I'm going to do, let's see, just because I'm trying to figure out if 3 will get pulled out. All right, so let's see, there's a 9, 3, subtract that's 1, and then 6, so that's an 18. So that's going to be, wait a second, 3 is 10, bring down 8, so that's 6, so 96, so 3 times 96. Okay, that's cool. All right, so then a 96 can be broken up into 2. How about that? So 96 be 48, bring down the 3, 48 times 2. Okay, so then I can break this into 24 times 2 times 24 times 2, and I have this 2 to bring down still. So I can bring out this 4, square root of 4 there. Got a 4 and a 3 outside. That makes a 12. And I got that 3 times 8 times 3. So I can bring out another 3 here. Bring out a 3 and a 3 there. So that is going to be a 3 pulled out. So 3 times 12 is 36. Square root of 8, which is 2 times 4. And then I can bring out another 4 there, making it 36 times 2, which is 72. Square root of 2 plus 14, which will then become square root of 3, right? So that seems awfully high. Let's see. Hold on a second. I made a big mistake at the beginning when I said the factors at 108 were 3 and 96. I don't know where I got that from. Right, so 108, 90, this, I don't know where I got this from. I don't know what I was doing here. Right, so we're looking at, it's going to be 3 and 36. I don't know where I got 9 from. I probably got ahead. I put the 9 here and put it set up here. Right, so it's 96. It's 9, and we're going to bring down 9 there. I mean, I messed up my long division. It's been a while. All right, so it's 1 here, bring down the 8, and then so it's 36. All right, so it's 3 times 36. I knew something looked wrong. Okay, and then 6 times 6 is 36, right? So I can bring this 6 out. Okay, so it's going to be 18 times the square root of 3 plus 14 times the square root of that. Looks more correct, right? Because if I square 18, it becomes 36, and 36 times 3 is 108. Something looked way wrong with what I was doing before. Sorry about that. All right, so 14 plus 8 equals 32. Right, 32 square root of 3. So 32 square root of 3, and that is my final answer there. So there's some proof to you there that, hey, if things just don't look like they're adding up, you probably made a mistake somewhere. Luckily, I recognized mine before I came out with the final answer there. A simple mistake with some low-level stuff. Even I can make mistakes there. Okay, so hopefully that all helps there. And hopefully you guys recognize that mistake before I did, and you're like, what is he doing? He is out to lunch. All right, so there's your Algebra 1 test review. 32 minutes and 50 seconds with writing and color coding and talking. Hope you guys understand all that stuff and can do better than me. I didn't make those mistakes.